Okay, it looks like we're live, so welcome back. Today I'm going to be looking into the Erlang virtual machine bytecode, which is actually called Beam. Yeah, so we can take a look at that on the Wikipedia page. Yeah, so Beam is virtual machine at the core of Erlang. Beam is part of the Erlang runtime system, which compiles Erlang source code into bytecode, which is then executed. So it is a virtual machine similar to something like Java. Yeah, and you've also got like Elixir and stuff, which compiles to the same bytecode. In a similar way, the Kotlin and Java work, essentially, is what it is. Yeah, so it's short for Bogdan's Erlang Abstract Machine. Okay, cool, I didn't actually know that. So, you may be thinking, this is quite similar to something that Zozing has been doing recently, and that would be correct. So, just for some context, give me a second here. Just for some context, here is this. So, he posted something on Twitter, or X, or whatever, and it's just a snippet from one of his streams, so I will play that, and then we'll go from there.
Some of you know that I lately been messing with the Erlang virtual machine, and I think whatever I came up with is actually pretty good coding interview question for software developers. For those who doesn't know, here is the problem. You have a file with the following format. You have a name equal number, name equal number, and you have to write a program that accepts that file and generates a binary file that is a valid Erlang Beam file, aka Erlang module. Right, and after loading that module into the Erlang virtual machine, it should recognize it as a valid thing. And that module should have the functions with the names that you provided in that file in here, and they must return the corresponding numbers that you made them equal to. Something like this. Right, you don't have to implement like an actual programming language, right? Just generate functions with the corresponding names, with the given names that return these numbers. And very important point, the program should not use anything from Erlang itself, right? It should be self-contained. The only thing it should do is read the given file and just generate a sequence of bytes. So the cool thing about this problem is that it's not a rocket science or anything like that, right? So the amount of bytes you need to generate for this specific file is 156. You can definitely figure out how to generate this amount of bytes, and the program that I wrote that does that actually is around, let me see, 280 lines of code of Rust, right? Specifically, the language doesn't really matter, right? So this kind of problem tests a lot of different skills that I think are useful for serious software developers. So what do you think? Is that
Alright, so that is actually it. So that is what I'm going to be doing. Hello, Alavaz, how are you doing? Oh yes, that's what I'm going to be doing. Yeah, I commented on it as well. And I got this. So, this is what, Mr. Zozing was using. I did watch some of the stream of it. Just parts of it, though. I haven't seen the whole thing, so going into it slightly blind, but that's what I'm trying to do. I didn't saw. Here, I can actually post a link to this. There we go. So that is the video that I was watching. It's just an explanation of what I'm doing today, basically. So it's a challenge, yeah. So today I'm going to be trying to read from the Beam bytecode, is what I am working on. So it's actually quite well documented. I'm going to be using C, obviously. Yeah. So let me write just a quick Erlang an Erlang program, and then I can look at the bytecode of it and sort of see how it works. So I'll just make hello.erlang. And let's see, I don't remember exactly how to do it. So I did have, let's see, I think I already had that open. Erlang hello world. I was looking at this earlier because I've never used Erlang before. So so I don't want to actually write hello world. I just want to return a number because that is the challenge. Yeah. So first thing I'm going to be doing is trying to read from it, so I can get an idea of how it's structured, and then I'll build the actual compiler. So we need module hello, so that's just the name of the module. Export, and then these are the functions that we're exporting. I do know that. And actually that is the wrong slash. There we go. And then we just have the name of the function. So actually I'll just yeah, it can be hello. And then return 15. Alright, so that is that. Assuming I did all right. And now we run Erl. And then let's see, you do C hello with a dot, and it did not work. Hello world, because that's not the name of the function. So yeah, my bad, I messed it up. I'm just gonna call it hello. There we go. Let me try that again. So C hello, and there we go. It reads it, and then I can call hello like that. And there we go, 15. So that is what I'm going to be compiling to. So we can take a look. It actually generated the beam file here. So I can look at that. Let's see. That's how you do it. There we go. So here is the bytecode of it. So I can actually can put that into a file. So code.txt. There we go. And take a look at that. So Elixir goes burr. Yes, it is the same virtual machine as Elixir. But this is Erlang that I was using. Alright, so yeah, this is the header, which is here, 4 bytes, you can see, 4.1. And then there's another 4 bytes, which we don't know what that is yet, but it is documented in here, in this one actually. And then we have beam, and then some other stuff in here. So that's what we need to read, essentially. Yeah, I know, okay. Okay. So, yeah, gonna be doing that with C. But here's sort of the structure of it. So here's a header. So this is the file header. So the thing at the start of the file, that's what we're looking at. The 4.1 and the beam. And then here we have a size. And it's in big endian, so I need to consider that. But this is the bytes remaining in the file, it looks like. So yeah, let me try to just read this. So it shouldn't be too difficult. May not see. Let me write a hello world quickly. I spelled it wrong, but that doesn't matter. Alright, let me do this. And I did. Okay. So I'm gonna do this. And let me build it. Alright, and there we go. So we need to read from the file. So I'm just gonna hardcode the file name for now. Equals fopen. Yeah, so it is hello.beam. That is the file that we're reading from, and we're reading it as binary. So that's what we need to do. And then, let's see, we can have close at the end file. Return 0. Okay, and then let me just make sure it is not null. Then, actually, I'll just, maybe, assert 0. There. I'll just do that so it'll crash. And I can make sure it doesn't actually crash. We don't have assert though. Let me add a couple of things I'm going to be using. Okay, so, oops. Alright, and it did actually fail, so is that not what it's called? It is hello.beam. So why is it null? Whoops, because I put it does not equal null. Okay, let's try that again. There we go. Now it actually worked. So, we need to read from the file. So, let's see. Man page of fread. This is what we need. So, fread, we have a pointer, which that's what we're reading to. Then we're going to have the file. The block size will be 1. And then we need size of something in here, which we don't have yet. And then we need some sort of a buffer. So this can be header. It's going to be a string, because that is the first thing in here. If I can, let's see. Got a little... Let's see, right here. This is what I wanted. Yeah, so this is the first thing I'm going to be reading. So right here, if I understand correctly, this means there's 4 units, and the units are 8 bits long. The unit size is 8 bits, so it'd be 4 bytes, essentially. So maybe I'll include int, and then just make something here, so like uint 32t is word, something like that. And then also 1 for a byte. Just so it is a bit easy to work with those. Because we could just use a regular int for that, but this is more clear. Because it is the same size. But yeah, so size of something. So we want the size of word, because we're reading 4 bytes. 4 bytes. And then the buffer, we need to have size of word. Yeah, so we need 4 bytes for it to store it. And then once we read that, we should be able to print it out. Hello, how are you doing? Print it out. Print out the buffer like that. And actually I can do something like that, I think. Alright, so let's do that. And there we go. We got the 4.1 from the bytecode, which I can open up the .txt 4.1. That's what we read. So the next thing here, we are reading the size, which is going to be big endian. So we need to consider that. Because it's not going to work if we just read it normal. So I'll try that, and it won't work. So I'll just make that size t, maybe just an integer. Maybe word even. So this is just the size. And it can be 0 to start. What is Beam exactly? Beam is the Erlang virtual machine bytecode. So here's the Wikipedia page. You can read a bit about it there. Yeah, so for the Erlang programming language, it's the bytecode of it. So in a similar way to Java has the Java virtual machine, Beam is just the Erlang virtual machine. Okay, hopefully that makes sense. Okay. Yeah, and then we can F read again, size of word still, except we'll read into a pointer to size this time. And if I try to print it out, it will not work. So, run that. And yeah, so that's obviously not the right number. So what is the right number? I can actually find out, if we look at this. So this is in binary, so that is 4. Maybe I should have done it in hexadecimal. But we need to look 4 bytes ahead. So that, okay, so we have 0, 0, so that's nothing. And then we have this one and this one. Okay, so if I copy that, let me look at, yeah, I've used this before. Let's see, convert that. 536, so is that actually the right size? -L. Let's see, we have 544, so 544 minus 8, because we've read 8 bytes already. That is actually correct, so that is what we're trying to read. Okay, yeah, so that is the correct number. Obviously, this is not right, because it is in big endian, so, we need to do something with that. Let's see. I think the way that we can do that is, instead of having this, we can have an array of bytes. Size buff. Yeah, and it'll be size of it, because that'll be the size of it. We'll read into that instead. Alright, so it's an array, so we don't need to pass the pointer to it. We still want to read the same amount, just into that. And then we won't be able to print it out. And then we have to perform a thing on it. So I'll use a loop. It's my birthday today. I'm finally 18. Well, happy birthday. That is awesome. You're going to convert a C program to a program readable by Erlang. Yeah, happy birthday. So, not exactly. Basically, what I am doing is, basically, to have a file, which is like this, 15, something like that, and then read that using C, and then convert it into Beam bytecode so that it will actually create a function called hello that returns 15. That's what I'm trying to do. Yeah, yeah. Then the Erlang virtual machine will be able to read it. Yes, so basically making a programming language. A very simple one, but one of those. And the hard part is having to decode the bytecode. Because once I have that and know how it's structured, then it won't be too difficult. I don't think. Word. I plus plus. Alright, so if I do it in a loop, then we need actually a word, and this is the actual size. And then we do size or equals size buffer, and we have to get the correct index, and then shift it by 8 times I. Is that right? I'm thinking read the file line by line and separate it with the equal sign. If there is no equal sign, return an error. Yeah, something like that. I probably won't even get to that today, the actual reading part, because right now I'm just working on this. But I will be using the string view library that I created, so that'll be fun. Yeah, so it's something like that. Let me see if that actually works. 0. So that did not work. So actually it might be the other way around. Size of word -1. While I is greater than equals 0. And let's see this again. Int then. So now let's see, is that's a seg fault. Why is that? I should have to shift it the other way. That could be it. I don't remember exactly how to do it. It's still seg faults though, so I don't know. I have a problem creating parsers while making the fourth syntax. I want to learn more. What do you mean you have a problem creating parsers then? Alright, size of buff I. That should be fine. Actually, I think I need a shift index. And then, yeah, it actually starts at 0. So I think it's like the opposite effect. So they need to go in different directions. It's still seg fault, so I don't know why that is exactly. Oh shoot, yes. Thank you. Yeah. 26, okay. So that's not right. So this isn't right. Let's see, is it just I? Variable shift. Yeah, so I is not right. Let's see, because I'm pretty sure we're supposed to do it this way. Might be the other shift that I was using. Nope, that's still 26. Okay. Oh, I forgot to iterate shift index, so I can do that. There we go, 536. So that is actually the correct number now. Okay. Trying to create the parser for the fourth language, but it's a bit complicated. I've never created a parser before. Yeah, it can be complicated when you first start. The fourth, it does make it pretty easy, where you can basically just split by space. For the most part, and then treat them all as individual tokens, essentially. Yeah. It's easier than making, like, for something like C or whatever, we need to consider a lot more things. I made a few of those. So you could look at those as well. They're not very good, because I was not familiar with the languages I was using, but spent a lot of time learning front end and doing things I didn't like. Yeah, I did that as well for a few years. Yeah. Glad I'm not doing that now. Okay. But yeah, so that is what I need to do there. Then I need to read into a buffer 2. Which I'll just call buffer 2 for now. And then that should be the next part. So I should be able to print everything out here. Print out buffer 1 size and buffer 2. Run that, and there we go. That is actually all that we need to read from the header. Right here. So that's perfect, actually. Okay. So yeah, I'm going to make a structure now. And this is just a file header. Yeah, and I can just put the buffer in here. So it'll be a character array buffer. Yeah, and it'll be a size of the word, actually. Will be the size. Okay. And then buffer. So actually, what is this for? So this one, IF header and form type. So I'll call it that. Let's see, form type. Alright, and then this one is actually, okay, which is basically the same as the character, but, you know. Alright, this is the size buffer. Okay, and they're all that size. And then we can just condense it down into one f-read if we make a structure, file header, f header equals, we don't need to initialize it. Well, we can zero initialize that, I suppose. And then read into the pointer to a file header. Let's see, size of file header. And that should pretty much be it. So then we still need to shift it. So maybe I'll make a function for this, like, just put in an integer, Bytecode big int. Something like that. And it'll just take a byte array. Let's see, like that. And maybe the size as well. Size, okay. Iterate over it. Well, actually, I can just take this loop. So this is going to start at buff size minus 1. Yeah, and it'll be that same thing, and then I need a shift index. And let's see, so this is just buff. Shift as well, and then just return the size. Not size, not shift. Have you tried human resource machine? I have not. What is that? This is a game? Okay, yeah, I have not played like any programming type games or anything like that. Yeah, pretty cool though. Let's see. Solve puzzle. The machines are coming for your job. It gives you a job automated by programming a little office worker. If you succeed, that sounds pretty cool actually. Currently free on Epic Games. Oh, it is. Very cool. I will check that out. Is it free for like their free game thing or whatever that they're having? For like Christmas or whatever? Oh yeah, we'll check that out. Very cool. Here, I will actually probably I'll bookmark that so I don't remember. Or so I do remember. Yeah, I'll just bookmark the page. Yeah. Okay. So yeah, so that should work then. And then here I can use the f header dot if header. F header dot no, this is actually just the size. Yeah, so the size needs to be Decode big and E. And yeah, we do need the size buff, so that is fine actually. And then this is just the word size, so that is what I'll need to pass here, size of word. And this I'll just make it an integer. Okay. Then I can print that out, the size. And then this needs to be header dot what was it? Form type. Okay. So if I didn't make any mistakes, I use variable shift index, okay. Get rid of that. Alright, so let's see if it actually works then. And it did not work. So this did not work. So I messed something up in here. Size, This is that's not the issue, but I don't think that's the issue either. No. So somehow I messed something up. Let's see, we're reading into that, size of that, 1, and file. Alright, and it is reading that, but then it breaks on the side. So why is that? Oh shoot, I forgot to actually pass, yeah, I need to use the buffer from the file header. That's my bad. File header dot, size buff. Is that what I called it? Yes. Okay, that is what I need to do. And that is not right. So I did actually break something. Oh, okay. So why did it do that? It was working outside the loop. Next, okay, about 5. Alright, what if I don't print the size? Just for now. I did actually read that one. I did it great while reading it. Yeah, it doesn't print that one. So the file header. That should be working. I don't know why it's not. Is it from 0 to something? I don't think it would be. No. These variable size, yeah. Oh yeah, so I had some issues. Why is it? Oh, I know what the issue is. I put it in the wrong order. Okay. Yeah, the order is very important here. Okay, there we go. Now it is actually correct. Yeah. So we have this, and we'll be able to actually use this once I'm trying to encode, or compile to the thing, because we can use the header, as a template essentially. So that's pretty cool. So now let me take a look at the next thing. So then we have chunks. And there is different types of chunks. Shoot, now it's gone. Right, let me put it back like this. Hang on. Okay, yeah, code, atom, stir T, things like that. Okay, so it starts with a chunk name, which is the same thing. So it's the same as that. So I'm going to read it one at a time again. I'll get rid of this printf here, though. So, yeah, fread. So, I'm not sure. Let's try to read the next chunk name. So, I will make a buffer. Size of word. Alright, and then we'll read into the buffer. Word and 1. Let me print what it is. I cannot type at all. Okay, print, it is a string. Alright, so let's see. Insert the size, that's okay. Alright, at U8. Okay, so that is what it is. So let me take a look at what that is. If I can search for it in here. At U8. So what is that? At, whoops, U8. Okay. Is mandatory. Alright, so either atom or at U8. Okay. It contains all atoms referred to by the module for source files. Okay. The chunk named atom is used for UTF-8 encoder modules. Chunk named at U8. Okay. So that's what it looks like, actually. Alright. yeah, so that is just the modules in it. So we can take a look at it in here. Let me actually do the changes. Bytecode. I want it to be hexadecimal instead. There we go. That is better. So yeah. So this is what we read for the first part. To there we read 12 bytes. Okay. So then here is the module information. Yeah, here's the at U8 that we're looking at. That we just read. And then the next thing for it should be the size. I think is what it said. The size of the chunk. Let's see. Chunk size, yeah. And it is read in the same way. Yeah, so we can do the same thing with the big endian and all that stuff. So, hang on, where did I... Yeah, I did that. Okay. I don't need this now. Because that doesn't matter much since we're not actually trying to interpret it or anything like that. We can read into, so we need a new buffer. That can... Okay, we are back. Good. Yeah, apologize for that. My internet has been, kind of dying the last few days, so, yeah. Okay, so decode big endian. Let's see. Noon's strikes, I think, is how you pronounce that. I do apologize. Followed, thank you. Appreciate that. The alert did not go off. I don't know why. It should have, but it did not. So, yeah. I have them set up. I need to look at that. But okay, we need to decode that of the size, and then size of word is what we pass in here. And there we go. So that should, actually an integer, that should be the size. Size of the chunk, 45. So is that correct? I can make sure that is correct. By looking at this, so what comes after this? So we have 4, 8, 12, and then this is the header part. It's like strikes, but with a Z of zig. Okay. Zig, so you like zig? Okay, so that, is that right? That might not be right. 4, 8. I'm not sure about that. 45. Let me see. Actually, so each one of these is 4, isn't it? No. I want to kill Zig by creating Bytecode and C. Nice. Fight between low-level language. They are all good, right? All good. Hang on, just... Alright, there we go. I've not used Zig before, though, so I don't know much about it. But nice. Okay, so, yeah, I'm trying to do this. I think I should probably use a better... do I have, like... hex edit or something? Yeah, that's what I want to use. So let me actually quit out of this. That'd probably be better. So, let me go into here. Alright, hex edit. Hello.b. Let's see. Alright, there we go. So this is better then. Because now I can see where I'm actually at. So yeah, I want to go here. So this is the name of the header. And then here is the size. So it's 2D. Okay, so does that correspond to 45? Let's see, we want hexadecimal. 2D. 45. Alright, perfect. So I was read correctly. Okay, and then what comes next? Let's see. So after that, we have the chunk data. So that is going to be a bit different. Because we need the chunk size. So that is what this is for. So I'm probably going to need to the chunk size equals this essentially. Okay. So that is what I want for that. And that is how much we have to read. Let's see. Yeah. And it's one byte at a time. Okay. Data format is defined by chunk name. So yeah, we need to consider the chunk name when reading it, because it is going to be different data depending on which one. Okay, and then padding. So I don't know what the padding is for. That is interesting. Okay. Well, I can try to read that. So what is the UT8 at U8? That is what I meant. Okay. So yeah. Atom length, number of atoms. So they are just integers, but in big endian, it looks like. It's hard to tell. Shoot, it looks like actually the next thing is number of atoms, so that is different then. And then we have these. Okay, so yeah, we need to read one more. Let's see, so we'll have the number of atoms buff. Alright, number of atoms buff. And it's the same amount. And then this can be number of atoms. And do that with number of atoms buff. Okay, and then I want to print it out. Let's see what it is. Alright, and mess some stuff up, so let's see. Use variable chunk size, that's okay. Specifies int. Alright, yeah, I want these to be int, obviously, so. Okay. So run that, and it is 4. So is that correct, actually? Let me open this up again. So 4. It is actually 4. We can see it right there, very clearly. That is 4. Okay. So that's the number of atoms, is 4. So that is what we need to read. That many times. Okay. Yeah, so I'm gonna take a quick break really quick. Yeah. Give me about 3 minutes. I will be right back. Okay, I am back. So let's see. So now we have the number of atoms. And then we need to read atom length 8. So it's 8. Okay. So I don't quite understand what this means exactly. Atom name. So the atom name is 8. Is 8 bytes then? Alright, well let me try just reading that. So I can make the character buffer. So this can be atom name equals size of word times 2, because that'll be 8. So maybe I should make something else. Something else to call it, but that's fine for now. Alright, we can read into atom name, read size of word times 2. And let me see what that actually does. So I don't think it's going to look quite real. But let me see. Hello. And then we have an M here. So it didn't quite work. So, let me see. Let me look back in here. So what comes next? Whoops. That's not what I wanted to do. Okay. So in here, yeah, here is the... There is something before it. So is that actually the length? So it's just one byte is the length? Maybe. Alright, let me try reading just one byte from it. So, and just into a byte. So, size. So I'll just call it size. It doesn't matter much. Do initialize and read it into here before that. Size of byte. So just a single one. And try to print that out. Let's see. Yeah, it needs to be a pointer, actually. 5. Okay, so, okay. So that is then the amount that we have to read. Okay, I see, I see. So yeah, we have to read 1 byte to get the amount to read after that. So, it doesn't say the endianness. Well, so I don't know if that even matters at that point on such a small scale. Yeah, so I'm not gonna do anything with that. But then we have size. So that is how much we have to read after that. So it's just sign byte times size is what we need to read into atom name. We can actually even initialize this afterward. Byte times size, like that. Yeah, okay. And then trying to print that out. Let's see. Hello. Alright, so it did actually work. Because that is the name of the module. So if I take a look at the URL file, module hello. So that's what we have in there. And that is what corresponds here. Okay, and then there's some stuff after that. Alright, so let's see what is next then. Then we have the padding. Padding 4. Okay, yeah, so I don't know what that does, or what the type is of that. Yeah, but we need to repeat for the number of atoms. So there's actually more atoms. So yeah, we basically need to do this, like in a loop. And so that's the number of atoms. And I need to actually create a big ending. Okay, just like that. 5 plus 5. And then do this. And then print them all out. So it said there was 4 of them, so that should work. Yeah, that's supposed to be a semicolon. Yeah, this needs to be like that. There we go. What is it? Size P and int. Okay, I can just cast this to an integer. Number of atoms, but okay. Yeah, whoops, I cast the wrong one. Doesn't really matter. Okay. Just like that's okay. So hello module info, Erlang get module info. Alright, so we already read through a lot of it, because you can see here. So yeah, this next one is the size that we're reading there. And then we have module info. Yeah, okay, that actually makes a lot of sense to me. So yeah, we're all the way to here then. And then we just have the padding. Ooh, okay. I understand what the padding is. So if we actually take a look in here, you need to align by 4. So that's what it is. So it was not aligned properly. So there's just the extra padding because it is not aligned by 4. So that is what we need to consider as well. Because we basically just need to discard the rest of this. Okay. And then we have the code block, it looks like. Yeah, we need to do that because of that is how it works. So yeah, align by 4. So we need to do that for the chunk length. Okay, so actually we can do that when we get the size buff, I suppose. The size buff is we print the chunk size. So we need to actually align that by 4 as well. That's 45. Okay, yeah. So we need 3 more for it to be aligned by 4. So that is the extra stuff there. Okay. So alright, let me see. So I can just make a function for aligning by 4. Align by 4, and it just takes an integer. And then we can do this exact same thing that they do here. Okay. Yeah, so we just need to return 4 times n plus 3 divided by 4. And that will align it by 4, which I can actually show. Align by 4. So say we have 45. Yeah, we'll make it 48. Yeah, 48, you can see. So it is working. So that's what we need to do. We need to call that so like a double thing here. For that. Okay. Then, it is not right. Because I did on the wrong thing, actually. Oops. It is this one. Align by 4. That's how we know the size. 48. Okay. So what can we do with that? Okay. So we need to know basically how many bytes we've read here, and we need to just read a little bit past that. Or let me print the number of atoms. Well, that is actually already 4. So yeah, so we just need to basically accumulate how many we've read. So we know that this is 4. 4. And this one as well is 4. And then this is going to be 4 as well. And then we read, then we read for each one of these, we have a set amount that we need, so I don't need to print that out. Let's see. So yeah, we don't know exactly how much it is, so we need to sort of like a sum. Total red. Just for clarity, I will do it for each one. Equals 4 plus equals 4 plus equals 4. And then in here, plus equals size. And then it needs to be size of byte times size. And then atom name. Oh shoot. Okay, yeah, we only need to do that once. And then it is not called red, so I don't know why I did that. Total red. Alright. Total red and total red. Okay. And then I want to print that out at the end. Whoops. Total red. 86. That's not right. So what did I do wrong? Plus equals size. No. Plus equals byte. Size of byte, because that is all it is. Alright. 53, so that's still not right. So I messed another thing up. Let's see. Size of byte times size. So we did read that much here. It should be 45. So the size of word, which is let's see, where do I do that? Word is 4 bytes, so that's right. Let me print this each time. Let's see why it is doing that. 7, and then it goes to 53. Why does it do that? Maybe there is a simpler way, actually. Okay. Actually, is this not included in it? These two, actually. Yeah, okay, so it is actually after that where it is, because then we get 45. So that is what the issue was. Okay. And then we need to just read the extra amount. So if we read into just no, can we do that? I don't know if that's a thing. Basically the size of byte times, let's see, what chunk size minus total red. 1 and 5. Will that work? It's segfault, so yeah, I did not think so, but we cannot do that. So, I can just read it into nothing. Yes, just be an int, nothing. Yeah, doesn't really matter, because it's just going to be 0, so we can just discard it. Yeah, let me just make sure that this is right. Size minus total red, so it should be 3. Okay. There we go. And then we should be able to read the next head. So we can make this, we can make a new structure for this. It does make it a bit more complicated though, since we have to use stuff based on the other information. So we can't just read it directly. But this actually is the same. Almost the same. Not quite the same. So yeah, it's not quite right. So for now, I think, I'm just gonna make it block header. And then I will put these in here. And I think that we can reuse them. So we need the name, let's see, the size buff, and then the number of atoms buff. Okay. Size, no, name, which is size of word string. Let's see. So then we need the size buff, which is the same as this. And then this one. Okay, and then we can read into those and use those. So if I get rid of those things and actually define it as a block header, the let's see, this would be the what was it again? It was at U8 header. Yeah, like that. And then FE pointer to at U8 header. Let's see, we want size of block header 1 and 5. And then we should have all of these. Yeah, so we need so size plus equals 4 as well for that. Total red. We don't need that. Equals 4, and then this will just comment so it's clear. Initialize total red to 4. Where's next? Yeah, I didn't really explain that very well, but I can change that later. Okay, so then we should have all those in here, and we should be able to use those. Yeah, so at U8 header dot that. F8 size of byte. Is that all that I need to use for that? Okay. And then we don't need these. We need the chunk size though. Okay. And then I should be able to print out at U8 header. Let's see, I'll just do number of atoms and decode that. Just to make sure it did state it. Big and medium. That, let's see, size of word. Let's see, like that. Build this. Number of atoms spot. That is my bad. Alright, do that. Use variable buffer. That's okay. That's nice and detected. Alright, so I broke something. Where did I do that? Atom name. Allocate that. Read that. Okay. I don't think it's from this. I'm pretty sure it's from the other things that we're doing. Yeah. So I messed up something here. Number of atoms spot. Which is this. Okay. At the end of the string. Okay, I see. Which one? Wait, which string do you mean? Read the file data into a buffer. Well, into several different ones. I'm not using these actually. Push that at the end of the buffer. Well, I'm not working with a string buffer right now, so so I don't need to do that. That's not what the issue is actually. I don't think. Yeah, I think it was because I forgot to get rid of stuff. So, because size buff doesn't exist anymore, so this needs to be at U8 header. Dot that, and then where else did I do that actually? Yeah, I think that was the issue. Yeah, that was what the issue was. Okay. So, yeah. So that's fine then. That should be good. So we did read it, and that is the correct number of atoms. So I'm assuming everything read. Okay, yeah, so we just read it and then kind of discard it. We don't necessarily want to do that. So we need like an array in here. Well, maybe not even in there. Yeah, it could be in here. No, that's not gonna work out. So I'll need a new one. This will just be atom body. I don't know if it'll be able to be used for the rest of us. That's why I'm calling it that. And then we need these things that we read in here. So we need the we need an array of them actually. So we need the name and the size. So, wait, what is, yeah, so atom size, and we need an array of these. So I'll just make it, let's see, that's not, I don't know if that'll work exactly. Okay, and then we need the byte of atom, whoops, atom name. So actually it's not a byte, it is a character pointer, atom name. Yeah, and just like 32 of those. So maybe I'll actually do like that, and then maximum character size. So I don't think it'll go past 32, so that should be fine. Okay. And I'll basically just push on to that, to be able to read from it. So yeah. Let's see, atom. And atom name. Yeah. Alright. Yeah, so that is a bit wasteful, but that way we can read it all into one structure. So we need the atom body. Alright, and then we're not going to be able to ever read directly into it, but instead into each element of the array. So pointer to atom body dot atom size. Well, it can just be called size, really. Because we only have the atom body there. So yeah, I think that is probably a good idea. We need the current size. So that is size len plus plus. That is what we're going to read into that. So yeah, we'll get rid of the atom from it. Yeah, because it's really not necessary. Okay. At least right now. Yeah, and then we need to read into these. So, yeah, we don't want to define a name like that. And then we need atom body dot atom name, atom body dot name plus plus. There we go. And that should read them all into the struct. No atom name. Okay, yeah, because it's just called name. Whoops, I got rid of the wrong thing. There we go. Okay, name, there we go. Run that. And it's segfault, so I probably did something wrong. Let me print the name this time. It might not be enough space. I might just want to allocate it. Let me do that, and I should print the previous one. Okay, so it breaks before that, so I messed something up here. Whoops. It's probably in here. Before that even, okay. What happened? Okay. Why does it break from this line? That is wrong. Maybe might need to use GDB. We'll see though. So this line might be breaking it though. Body.name. Let's see, that should still work. Yeah, so it's not from that. This isn't right. Size is not a thing anymore, so we need the current size. So dot size and body size, and it's very verbose. But that's okay. Okay. Yeah, that wasn't it, but that was still a problem. Okay. So I don't think it's from that. Yeah. It's something that happens before this even though. No. So that does work. Okay. So it's from this. Reading it into that. Why not? I'm supposed to, yeah. So it doesn't like this line. Maybe I should. Okay, I think we are back now. Yeah, it died again. Should be good now though. Yeah, okay, I think we're back. Maybe not. Alright, I think it is back. Sorry about that again. My internet keeps dying. Okay, let's see, what was I even doing? Yeah, so I was doing this and then printing them out. Antibody dot name. There we go. Alright, so we can print them all out. That is good. Alright, and then yeah, let me just read this into nothingness so that it's okay. Okay, chunk size is aligned by 4, so yeah. So I think I'll add maybe this total red 2 here as well. Alright, and then just use that rather than this. So add a body, okay. Alright, and let's see. There we go. So that works. So now it should be aligned properly, and we should be able to read the next thing, the next header. Yeah, so let's make another header. Now like size of word. Okay, and let's see. Okay. And let me print it out. And it should be code here, if I remember correctly. Okay. So, code. There we go. Let's see. I don't need to print that out anymore. So we're on to the next one. So we're just working our way through it. Okay. So, what is this? So then we have the size, and then something else. Let's see. Presla VND followed. There might be a better way to pronounce that. I'm not very good at doing that. Thank you. I appreciate it. Okay. So my Twitch is broken. Okay. So let's see. Yeah, so we're reading the code. Now we need to get that. Basically. Get the stuff from it. So let's see, where are we at? Yeah, so we have the code. Oh, there we go, right here. So yeah, this has quite a bit of stuff here because we have the instruction set and all that stuff. Let's see, story T. Yeah, so we can see some other headers here, but this looks like it is all the code. So that is what we would be generating. Once we get to that. Give me 1 second. Okay. So yeah, that is what we're trying to do. All right. Yeah, so we can read that, and then the next part is the size as well. So yeah, I think we can read this all the same. But we don't have the sub size, so that is different. And then the instruction set. Must match code version in the emulator. Okay. So let me read that. So yeah, it's not exactly the same as this. Because it doesn't have a size and then or is it number of atoms? So yeah, subsize. Okay. So I'm not sure exactly what the subsize is, but I think we can basically reuse that. I'm not going to rename it though. But yeah, we can just basically read into another header. So let's see, block header. And this will be code header. Initialize that. I'll zero initialize it as well. And just read into code header size of block header. And then we should have the data for it. So I print out code header What do we have in here? We have name, size buff, and number of atoms. Which it is not really going to help. So I think I'm going to change that. It is going to confuse me. We do have that, so we did read the name properly, which was expected. So let me change this to instead like sub size buff, because I feel like that would be easier. Then I need to fix some things. So let me see where the compiler says though. So this must be the only place. And there we go. Okay, so yeah, then I can print out the rest of it as well. We got size, and we need to convert, we'll decode it. Like that. And yet again, with the sub size buff. Sub size buff, word again. Okay. There we go. Build that, and I messed that up. Number of size. It is size buff. And this needs to actually match here, so I need that and that. Alright, I missed some parentheses. Okay. Now, there we go. 70 and 16. So is that right? Let's see. 46 is what? 70. Okay, so that is right then. The next one is 10, so that is going to be 16. 16. Alright, perfect. So we did read it properly. That's it. There we go. Okay, so yeah, the code header. So we are working through it. So then we need to read the instruction set. Which is just another number. So just, well, it's going to be the same way. So it is going to be a byte array. It's set. Times of word. Okay. And read that. Alright, do that, get rid of that, and then print out the number corresponding to it. Code. Instead, size of word. Build that, run it. We get 0, so it is 0 here. Then we have A9. What is A9? I feel like 0 is not right. So A9 is 169. Nice. Okay. So in the emulator, what is it? So Earl. Actually, is it 14.2.1? Let's see. Can we do dash B? Actually, there was B. 14.2.1. So what is the code version in the emulator? Code version. How do I get the code version? Yeah, I don't get what that means. Alright, well, hey, what is supposed to come after that, actually? After that, let's see. Then opcode max. Okay, label count. Function count. Chunk minus subsize. Divided by binary. What is binary? Oh, it's binary. Okay, the data is binary. Alright. Okay. Alright, is it just 0? Alright, Alright, well, I can just keep reading and see if we run into errors. So, alright, so we'll make a few more for instruction set, opcode max, label count, function count. Let's see, label max, label count, function count. Alright, function count should be 1. So I've read into all those. Mm-hmm. That was first, actually. Okay, so I can print them all out individually. So let's try, let me try function count first. That, I feel like that is not the right number. Okay. Function count, how about label count? That is not right either. Cause of this, actually. Okay. Ilian Asinopol. Okay, I just completely butchered that, and I very much apologize. But you just followed, thank you. I'm very bad with names. I'm sorry for that. That's still not right. Hang on. Label count. Yeah, that is still definitely not the right number. What is that? Yeah, so something is not right here. Let's see. It should be. We should have made this. Like this. Okay. Then we should have gotten 7, then 3. So what was A9 again? It was 169, I think. So why did it not read that properly? So, did I actually skip something? Chunk name, chunk size, subsize. So we read all that. Then we read inst set. Oh, shoot. I see what's wrong. Use the wrong side. First part of the parser is done finally. Very nice. You mean the tokenizer, or how do you mean? Like what part? There we go. That is right. Okay. Label count. I think that should be 1 as well. That's 7 actually. Okay. Function count. Tokenizer. Nice. Very nice. 3. Alright, so why is there 3 functions? Alright, so what happens if I try to read into function again? What is the next thing? Alright, so it is not a number. So, this is going to be the code. So, we did actually read it all properly. So, I don't know why this is 0. Why would that be 0? I don't know. So, it's a number of words. Which version of the instruction set? Whoops, there we go. Okay. The version number is increased if any instruction is changed in an incompatible way. Okay. Here's the highest number of any opcode used in the code. Okay, and label count contains the number of labels so that a loader can pre-allocate a label table of the right size in one call. Okay. Code field contains instructions chained together where each instruction has the following format. Alright, so here is an individual instruction. So let me make, I could probably make a structure for that as well. Yeah, so the arity, how do we get that? Yeah. Because that's like the number of arguments. So instruction code. Let's see, parse code info. Code size that. Okay, let's see. So what I need to read this now. Read that just into something. Let me see what chunk size minus subsize is. So we have chunk size and subsize. So yeah, that should be pretty easy to figure that out. So put that. Let's see. Decode. We want code header dot size buff. Code header dot subsize buff. That is actually not right. Because it's not like that. Yeah, so I need to do that and then do this again. Okay, there we go. That, and let's see. Alright, I messed up that. Shoot, no, I want to subtract. Alright, let's see. So we get 54. So is that right then? So that's the code. size. Okay. So that is how much we have to read then. So I could actually assign this to just a variable for now. Code size equals that. Alright. And then we just need to read that many times. Read that just into something. So I'll just read it into like an array of bytes. Code. And yeah, so it'll be code size. No, 0 and side. Can I do that? I think that is something that you can do. And then we can just read it. Code, the size of byte times code size. 1 and 5. Alright, and let's see. Right, doesn't like me doing that. Alright, so we just iterate through each byte. Then code size. So yeah, they're not integers, at least not all of them, so that is fine. Yeah, so we print out some stuff here. There should be a 15 in here, because that is what we're returning. So I think that is where it would be stored. Maybe not. Yeah, it's really just random numbers, but let's see. We do if I equals 15, then I'll be able to actually check. Alright, it is not, so I need to do code size plus 1 actually. No, I don't. Okay. Yeah, so I don't need to do that. But what would come after that then? So what is after the code block? So we do all this. Alright, let me see if the next thing is 30. Might not be. Sorry, word, and I'll just see if that is what we do. Word and 1, 5. Into F. RT. Okay, so we did read too far. Oh, because we did not align it, did we? We probably need to do that. So, yeah, the chunk size. I think we just align the chunk size, right? Oh, let's see, align by 4. Or it might have to do the whole thing. I don't know exactly. Yeah, it might have to be the whole thing. So, let me try it. No. Alright, so something is not right. Maybe. Maybe we have to do them both individually. We definitely need to do it to something, so. Let me print the code size. And 56, okay. So when we get to stir T, where is that at? Right there. Okay, yeah, so we have 2 extra there. So that was actually right? Because if I don't do this, then what do we get? 54. So it needs to be 2 less than that, actually. Let me just see. Yeah. So why is it too much? Because that is 1 by 4. And we subtract 2 from it. But we want it, like, it would overflow. So I don't quite know. Let's see. Subsize buff. Are we reading that wrong? Name. Equal to code. Let's see. We need for each one. And then print, let me set codes up as well. Print them out. Shoot. Actually, this is supposed to be, yeah. Chunk size, there we go. That's fine. Okay, and also print out the sub size. Code sub size. Let's see. So, 70 and 16. If we align this by 4, then it is 56. Yeah, so it makes it more. That's not good. So, let me go back here. So running for the code, we have 46, which was 70. Yeah, that is 70. Then we have 10, which is 16. Yeah. So why is it not right? I must be reading one too many of something. Because like we'd be reading one too far. Because then if we aligned it by 4, it would add 2 to it. So which one of these am I not supposed to be reading? Let's see. Function count, label count, opcode max, instruction set. This shouldn't be one too far. Block header. Because we have these things. Which is alright. Yeah, if I just got rid of one of these, and that was aligned by 4, then it should be, then it would be the right thing. Or not. Let's see, what happened there? Oh, that's not right. I forgot to align my 4, okay. Yeah, then it reads the right thing. So one of them is not right. Huh. Code header. Is it the int type? Because that was the only one that was weird. It was 0. So it was kind of weird, but it says that that is a part of the chunk. So yeah, right here, this would be that. And that was where the int set 0. Huh. And then was that one, A9, which I don't remember exactly what that was. 169, yeah. Yeah, I don't quite understand. So let me work through it. So this would be the int set. Then this would be code max, label count, function count. Then what is this stuff? Oh yeah, so this is all the code then. So we do that how many times? It was 54. Yeah, all the way through here. Can I like nope, I'm overwriting stuff. I didn't do that. Okay. 54. Starting from right here. So yeah. 4, 8. All the way to here. And then yeah, there's these 2 extra for the align by 4. It all makes sense, it's just I don't understand it. Don't understand it's one thing. So why is there not that? Because yeah, this is right then. It's the right size, being right. So am I overreading somewhere? What is size of block header? It should be 12, I think. 12, yeah. So that's actually right, because we have 4, 8, and then 12. Wait, if I go back here. Yeah, so we have 4, 8, 12. Okay. So that is reading properly. So which one did I do one of these wrong? No. Yeah, I don't understand what the issue is. Like why is that not right? Because it is quite important to have these fields. Huh. Hmm. Yes, I don't know. Well, I mean, I can keep going. I'll try to actually make a code body. Alright, let's see. So we have these things. So, we could even put the code header in the body. Probably won't do that, but I could. We're not using all these, so, yeah. I'll do it without the int set for now. Put them in here. Okay. And then what else was there? Then we have just the code, but that needs to be allocated after, so, well, it could just be a pointer, so. Bytecode. Yeah, and then we just need to allocate that space. So then, yeah, we can make a block code body. 0 initialize. F read, Actually, that's not gonna work. So, yeah, I'll have it be separate. I'll get rid of this. We'll just have that be a separate thing. That is okay. Get rid of these. So yeah, I'll just kind of leave this like this. I just need to change this to. I don't need to change it to anything. Okay. Yeah, we're using that. So what fails? Variable int set. That's okay. And there we go. Okay, so then we can move on to stir t. Yeah, I'll need to figure out why that is though, because that is a bit of a problem. Yeah, we can look at stir t chunk. String table, yeah. So that's where all the strings are stored. I don't think we have any strings, so it's not very long. Okay. Yeah, so we're getting there. We are getting there. So let's see, what is this? Okay. Yeah. So then data. Yeah, so that is that's the strings. So the cert name. Okay. Then we have the cert size. Cert size bug. Yeah, okay. And it is going to be just a byte array. That's word, okay, and then print it out. But decode it. Size bug. Size of word. Alright, and it's not a string, so I don't want to do that. Whoops. Stir T. For the name. Alright, 0. That is probably actually right, so. Yeah, so 0. That is correct. And that is all that we have there. So then the next one will be empty. So we should actually have something. Well, it doesn't matter in this case. Yeah. So I'm not trying to actually build an actual thing. I'm just trying to get a sense of the size. So we don't need to worry about that. Yeah. So this next one. Okay. So this is empty. Same thing except different name. This one is actually. Alright, and then I can count the size of that. Alright, let's see. 28. So actually, let me just make sure. So attributes chunk. So that is not right. Let's import table. Okay. Contains information about which functions are imported. Okay. So I don't think there's much here either. Well, it looks like there might be. Yeah, I guess the size is 28. So how is that structured? So we have the size and then the import count. Okay. Yes, we need to read one more for the count. Size of word. Okay. Read that. And yeah, I want to do that with the count. Alright, 2. So there's 2 imports here. Let me make sure that's right. So we have that. 1C and then 2. Alright, perfect. Okay. So then, what is next? Module name, function name, arity, and then repeat for import count. Okay. And the padding is based on that. So yeah, this should not be too difficult to read. Okay. Alright. Yeah, we're working our way through the file. So, yeah, what do we have? So we need basically a structure for this, probably. This can just be for, import. So we need a name, which is a, I guess it is, so, name, function, name. Yeah, so maybe I should call it like that, actually. So, this can be, module, mod name, and then arity. Alright, that's all that we need to read from there. Okay. So, we read it, import count number of times. So, yeah, we need equals size of word for count plus 5 and just every. So I will declare actually a import. No, so we need an array of them. So count. Alright, something like that. No, I don't need that. Just as long as it reads the right amount. Oops. Alright, what is this? Imports a parameter of that. Oh yeah, it needs to be a function. Okay, and it doesn't segment, so that is good. Good so far. Let's see. So after that we need to see if we have the padding. So I can see there. It looks like this one won't need it, but we should try it anyway. So we just need basically a count. So that comes after the size, right? Count plus equals 4, okay. Plus equals, so what is this? Size of input, I suppose. And then printf that. So the count is the amount read. Count is 28. Okay. And then the size is what again? Let's see. Because that is how much extra we have to do. So I think it was 28. Yeah. So we read the same amount. But we need to still figure it out. So we need that. Minus. Okay. And then yeah, so we just set this to the difference. Equals that. Okay, and then fourth arithmetic done finally. Nice. So you got like the parser done then? Okay, diff, and then yeah, we just need to f read into nothing. Alright, so byte times diff. There we go. And it's gonna do nothing. So yeah. Then the next thing will be the next header. So yeah, what is gonna come next? XT. So what is that? XT. So it's the something table. Export table chunk. Okay. Mandatory and contains information about which functions are exported. Okay, so that is important. Because we do actually export stuff. So yeah, we export hello. Okay. All I need is the string stuff and the stack manipulation, which does not look very hard, but the string is going to take time. Yeah, the string part gets a bit difficult, yeah. That's probably the hardest part, the string stuff or the memory stuff. Okay. So maybe actually, I haven't been making commits on this, so I might actually do that. So I do need to initialize a repo. Let's see. So yeah. Let me go, let's see. Should that worked? Okay. What else? And should I commit the bytecode? I can probably do it, that's fine. Okay. So let's commit. There we go, just so I can sort of track some progress, you know? Okay. There we go, and now it is up. Whoops. Up here. There we go. Alright. Yeah, so now I'll start, once I complete certain sections. Okay. Let's try to read this. XPT, the header. Type of word. So this is read into XPT. Word 1. 5. And now. Okay, so we are in the right place, so that is good. Alright, so what is next? We have that, and then what does it contain? So we have the chunk size, export count, and then these are, okay, so actually it's the same thing as the imports. Almost, it's almost the same thing, it's not exactly the same, but I think we can reuse it because it has the same things. Shoot, it's just the wrong order, which isn't great. Yeah, that makes it a bit inconvenient. So maybe I'll just make, I don't know. So we can export. And it'll be almost the same as this. We have a function name, linearity, then label. Alright. Yeah. So this is read sort of the same way. So yeah, we have all these same things. So this could probably be like a struct, and then we could actually reuse it. Yeah. So I should probably do that, but I don't want to do it yet. Let's see. I can do that. Let's see. Function header, and I'll put these in there. that, and that. So this will actually be an array though. Like that. Alright. And there we go. And then function header. And this will be empty. And we'll put that in here. Let me rename it though. So we have name, size buff, and count buff. Okay, empty header dot size buff. No, this is the name buff. So yeah, just name. Okay. Name. T header dot size buff. Count. T header dot count buff. Okay. Yeah, then we have the count, all that stuff. Alright, let's see. And this does not work here. Whoops. Okay. The header, that is in here. There we go. Okay, and it should all work still. There we go. I can get rid of some of these print statements. Okay, and then we can reuse that here. So this will be xt header. And can do the same thing. So yeah, actually this, I don't know why I did it like this. Header, yeah, side of function header, 1 and 5. Then I can get rid of all of these. Alright, and it does work still. So yeah, then xt header, and you can f read that as well. Function header. Okay, and then we should have header dot name. What is this? Needs to be a pointer. Okay. There we go. So then, yeah, then we have the size and the count. And we need to do the same thing that we did up here, basically. This is export count. What's that? But this is the header, okay, and this will be exports. Speed count, okay. Size of export. Exports high, okay. Alright, let's see, that should compile then. Like that. And let's see, repeat that, and then, yeah, we have the padding again, so we can do that same thing. And we can see what the difference is as well. But we don't have a count, so that's not going to work out, because we need to set count equal to 0. Or count equal to 4, rather. There we go. And yeah, so diff, we just do it like that, that's fine. -8, so that is not right. I forgot to increment the count somewhere. Or some, oh. There we go. 0. Okay, so it is still the same. We can still read past it, that's fine. Let me just make sure. So the next header is meta, it looks like. Yeah, so it does go all the way. Alright, so then the next one, we can read that. Probably the same. Let me look, actually. Meta. Meta instructions. Where is it? Huh. I don't see it. Here, let me try to read. Just a button. Type of word, okay. word 1 file. Okay. Alright, let's see what happens. Meta. Okay, so what is meta? Meta. Hmm. Yeah, what is this meta header? And it has values following it. Yeah, I don't know what this is. So this is just like metadata then, right? And is that the last header actually? It might be. Well, alright, we can try to read the size as well. So if we make a byte array, word, okay, and then fread into size bar. Kind of print it out. Sign of word. Alright, let's see. We get 28. Okay. Then what if we just do it again? Oops, I messed that up. Okay. Yeah, so that does not work. The next thing is not a number, it would seem. Yeah, so it is some characters or something. Shoot, it's probably actually a size again, so we have to read a single byte like we did before. Like the count or whatever. So what is 83 actually? 83 is 131. Okay, so 131. Okay. Where can I find this meta? Let's see. Let me go back up here. Literal table, yeah. Where's the meta table? Or it's not even a table. It's like uh, let's see. Meta. Meta. Let's see. I just want to know what the meta is. I mean, obviously it's metadata, but I don't know how to read it. Let me look, actually. So what did I do for the code? Was it code? No, it was the, which one? The, yeah, it was the atoms, actually. And we read it into that. Huh. Yeah, the next size is 28, so I'm assuming, oops, I'm assuming that is then going to be that. And then we read one more byte, so then after that we have to read something. I don't know what all this is. That's probably just padding. This is probably reading another thing. This is going to be 16. Is that actually the length of this? Let me actually do that. Enable the features. That is 16. Okay, so that is what we're reading from there. So like this is 16, and that is the length of that. So this is 0. And then 1. So that's a 1 actually. So we're reading 1 there. What is this one? Why is that 83 though? And 6C. What is 6C? 108. Huh. Yeah, I cannot find where that's at. Da da. Hmm. Huh. I'm assuming this is all the rest of it is just the meta. Huh. Let's see. Meta. Da da. Let's see. Does anyone say anything about meta? Da, da. Yeah, maybe it's after these. Let's see. Encryption. Da da. Impression. Yeah, this isn't what I want. Abstract. Do we have abst in here? Oh, we do have adder. Okay. Ooh. So that is another thing that we're gonna read. But it's after the meta. So how do we read the meta? T, yeah. We have adder. Let's see, where was that at? Adder. Yeah, attributes. Let's see. Uh-huh. How do we read this? So I read this. What was that again? 28 or something? Yeah, I think so. 28. So that was what we're reading. You read one more after that. That's the size of something. Then we have that. This is just alignment. This is 1. So we have to read 2 bytes actually for the size, is it? Could that be it? 36C. That's a really big number. I feel like that's not it. But it could be something else. It could be metadata. That would make sense. Read 2. But then why is there zeros? Yeah, that's a big number. But then this, yeah, that would make sense reading 2 here then. That's the size of this. I don't know what the O2 is for though. Yeah, it's hard to just work through this. Let's see. On Apache. Bytecode, let's see. All the way to what? Pretty slow. I need to close it. Let's see, that might be useful actually. Mid. No. Dang. I don't know what it is for then. So what is the only thing? Enabled features. And then we have 2 more things here. But they're not alignment. 6A, 6A. So what does that mean? Huh. Uh-huh. And I can't really just like skip past this. Let me see actually. Let me see if ChatGPT knows. Beam bytecode. I'm assuming not, but I can check. What is the meta? Okay. Yeah, that is what I was talking about. What is the structure of the chunks? Of that chunk. Lisa Pisa or Pisa followed. Thank you. Appreciate it. Yeah, I don't know why alerts aren't working right now. It should be though. Okay, I don't have specific details of the structure of the meta chunk. Okay, so it doesn't say anything about that. Topher, nice. Let me see. Yeah, I don't see it anywhere really. And I don't know why. Okay. Beam file format. Yeah, I just want... This is the file header. We got that. We went through all these. Let's see. This doesn't say anything about meta. Let me try that actually. Early. We do... No, actually, we don't have that. Okay. I didn't actually realize what I was doing. Yeah, I see now. So that is from a file. Okay. From a file that reads it. Let me try that. So what if I take this and make it an actual file? Do that. And arrow. Test.arrow. Huh. Alright, so it doesn't like that. Where was it? 1.7. Huh? I don't understand. What? Yeah, it doesn't seem to work. Well, let's test actually. It's actually going to be called beam file. Okay. Okay. In the beam file, read file. Alright, and then we do have meta here. So maybe we can get an idea of how it works. But read, oh, hang on. Read, hello.b. Okay. Yeah, meta, so we get 28, yeah. Okay, let me see how that works then. Let me move all these. Hello.b, yeah. Alright, that should be fine then. So what is this doing? Okay. So this is the first thing, and then we read chunks. Okay, rest. Yeah, so where's rest defined actually? Yeah, rest. Okay. That's the rest of it. Size chunk. Okay. So that works for all of that. Yeah, it just reads the rest into binary. So can we just read the entire thing over through the amount of size? Chunk length is binary and the rest. So this is the chunk length, right? 28. So what if I just read 28 bytes? It's enough. Nothing. Let's see. Defines big ending, size above, something word. 1 and 5. Do that. And then try to read I could read this into the to just the header of for now. Word. I don't think it's far enough though. Okay, let's see. Okay, did actually do that to lock T. So where is that? Lock T. Okay, right here. So that did work then. So we just skipped over it, but I don't know what we have to put here necessarily. So that is the problem. Because when we're trying to compile it, we're going to need to know what to do with that. Or is it not required? I don't know. Suppose I will find out. Okay. Well, yeah, so that's fine then. So now we're on to lock T. So what is that? I know that was in here. So it's a lock table. Local function table. Okay. So that is an important one, actually. So yeah, we can read that the same. The same as we read the other ones. The other function thing. So function header, yeah. This can be lock table. Pointer to lock table header, size of function header. And let me do header.name. Yeah. Okay, we get that. And then I have to decode the size, so I don't want to do that yet. But then, yeah, then we read through it the same way as this. Function name, arity label. So that is the same as the export one. So I can do it the same way. So we're gonna have to do basically this whole same thing, all the way down to here, actually. So yeah, count this except log. This is log count. Count, okay. Let's see, logs. I'm still going to call this export because that doesn't really matter much. And then this is log. Print out div, and let's see what we get for that. 0. Okay. Is that actually right? Is it supposed to be aligned properly? Yeah, it looks like it is. Okay. So that should be fine then. And then if I have to read nothing, yeah, do the same thing that I did up here. Okay, just like that. Okay. And then we should be able to read the next thing. So, get rid of some of these print statements. Alright, and then then just have to read into another buffer. So this is gonna be for the attributes. So sorry, word, and it's not actually word, so that's right. It is buff. And actually I'll call this adder. Adder, and print it out, make sure it works. Okay. And adder. Perfect. So we are all the way to here now. So yeah. Option, yeah, so there's always a lot of stuff here. Let's see what adder looks like. So attributes. Yeah, attributes chunk, that's what I want. Okay, so it is structured like that. So we need the chunk size. Okay. Yes, then the attributes, okay. But some of the tools, it's optional, okay. The release header expects the VSN attribute to be present. You can get the version attribute from a file with that. Assumes that there is an attribute with a VSN attribute present. Okay. So we parse it like that. Alright. I think I can do this then. So that's the name, and then we have the chunk size. Fine. Size of word. Okay, and F read into adder size. Then I can print it out. Coding it. Size of word, okay. And let's see. That's not right. Yeah, because I double printed that. So 39. Okay, and is that actually correct? 27, which is probably 49 in hexadecimal. 39. Perfect. Okay, so that is the chunk size. So where's the end of this chunk? What's the next chunk gonna be called? So I think the version is stored in here. So 29. Then we have to read the rest of that. So I'll just read it into nothing because we don't care about it. But we do need to pad it. So yeah, we can make the size be simply above. This needs to be added size. Okay. And my 4. There we go. And then we need to just read into nothing with just the rest of it. Size of byte times added size. And 5. Okay. And then right, and then we should be on to the next thing. So this will just be header. Read it into header. 29. Let's see. Alright, sync. So what is that? So maybe system information. Let's see. So compilation information. Alright, that makes more sense. Alright, let me actually paint it. Progress. Not a very good message, but that's okay. Alright. Making some progress. So, whoops. Alright, so that has chunk name, chunk size. Alright, so it's the same thing basically. Same thing as this one. So, let's read it in the same way. I could just make a structure for it, which I probably should do, but I'm not going to do that yet. Let's see. Let me just actually clearly replace this. Oops. Nope, that's not what I want to do. Header with CA. Alright. Files. Alright, and that'll be the same thing. So that should be fine then. So what is the next one? Header. I don't know what it is yet, so header. Print it out. And I probably should have printed the size as well. Okay, let me actually do that. So print out the size and see what we get. Let's see size. Okay, get that. 92. Alright, so that was actually a pretty big one. So what is DDGI? DBGI, my bad. Still up there. Debug. That it's probably debug information, right? Where is that at though? That's here. Alright, so this actually was where all that stuff was. So we probably need to know how to encode that, but it shouldn't be too hard. Yeah, DBGI. Yeah, debug info. So I can see that. So if I actually just read the size thing. Is size buff, debug size buff, and debug. Debug. There we go. And then do this stuff. So this will be debug size. Debug, okay. And let me print out debug size as well. Alright, so let's see. 48. Alright, so we are pretty far in. Probably line or something like that. Now, we can find out though. Okay. And I would just print it out. Alright, let's see. Line. It is line. Okay. So we are all the way down to here. So we're almost done with the whole file. Line. And then the next one I suppose is probably type. So let's see what line is, if it's in here. Line. Stack manipulation done. Let's go. So you have like the, let's see, what's it called again? Like the swap, dupe, rot, stuff like that, right? Is that what you meant? Parsing's line. So that's the only mention of line in here. Chunk. Yeah, very nice. What language are you doing again? Go or C? and go. Nice. The dot and emit, and then the string. All right. Dot is pretty easy to do. Line. So what is next after line? It's not a good idea making it in C since I don't know much of the language. Well, I think it's a good way to learn the language. In my opinion. Especially if you do it in Go first, and then you know how it's done, sort of, and then you try to basically convert it to C, you know? I think that might be a good idea. For learning it. Yeah, and then do this. That's what I was saying. Nice. Debug with line. And line size. Yes, this one is probably quite large. 24. Yeah, and then the next is probably going to be type. Whoops. So I grab all this actually. I can just basically do the same thing. Place line with type. Alright. Yeah, let's see what happens. So, 12. Alright. So what did it actually type though? It was that. Okay. So that was probably the end then, right? So I'm trying to read nothing now. It should actually fail. It doesn't fail. So what does it read? I don't think there's anything else. Oops. Let's call this header. Type with header. Alright. Okay. So yeah, there shouldn't be anything. It'll probably prints nothing. Okay. So I don't really have a way where I'm showing how much, but let's see, can you get like the so this is probably offsetting the file pointer, right? So maybe I could even make a copy of it. So let's see. File copy. Yeah, and then connect that. Let's see. Copy minus 5. Or maybe file minus copy. Like that. Alright, so it is 0. Minus 5. 0. Okay. So they're the same still. So it doesn't offset it, I suppose. So I don't know how to do that then. But we did read through the whole thing, so I have an idea of how it's structured now. So basically I just need to do the opposite of this now. Write it into the file. But first I need to read from the file. So we make like a let's see. Hello dot let's see. I think it's Erlang and C. So root, open that. And so this is what I'm finding two parts. Hello equals 50. Something like that. Yeah, but you can have as many of them as you want. So that is what I need to do, and then I need to convert it into bytecode. So I need to figure out how, really what I need to do is look more into the code part, though, because I don't quite understand how that works. Well, yeah, because the code has some stuff in it. Yeah, I need to figure out which ones I need to write to, essentially. Some of the stuff, it is kind of just metadata, you know? Yeah. But this is sort of the structure of it, so I can use this as the structure for it. So let me finish that. Add dot. Unverbal copy, I can do that, yeah. Finish the reading of the file. Alright, yeah, so I'll start on the actually parsing the file, and then I'll probably have to end the stream. Yeah, I should be able to get pretty far in that. So what I'm going to do is I'm going to take my string view. Let's see, where's mine? View, there we go. Okay, string view. Oh, and actually I want the... Shoot, I didn't make it a header file, so yeah, it's going to make it a bit harder to do. That's okay, though. So I can just copy this. view.h. Go. View.h. Whoops. No, whoop. Can't connect. Did I break something? Let's see, let me go here now. Doesn't like that. Okay. Let me see. Yeah. I can just copy it. Then put it into there. Work? Okay. View.c, okay. There we go. And then I'll just import this and link with it. Can you just actually import the whole thing like that? Include view.c. Yeah, I can get rid of the main function. I forgot to make this a header-only library, so it makes it a bit harder to do. Alright, let's compile now, so I think I can use it like that. So, yeah, if I define a string view, so I'm gonna make this actually the old name. Make a new one. Okay, needs void as well. So file equals fopen hello.earl. That's what I want. Right now I'll hard code it. I'll do this thing again. Okay, now actually Earth is what I want to do. Okay, and then I want to... Why the easy forth web is so bad? What do you mean? Why is it bad? It's a bad website? Let's see, and then I want to do fc. Look at fc. The fc. What is it? So, file, offset. Okay, yeah. So, and then I think it's 0. And then cn. Then length. And then seek set to go to the beginning. Alright, and then I go length, and that's what I'm going to read. The movement is snappy, at least in Firefox sometimes. It just scrolls to the top for no reason. It does. Well, that doesn't happen to me. It hasn't, at least. And I've used it quite a bit. Yeah, I'm not using Firefox, though, so that could be it. Firefox do be like that sometimes. Alright, I then can fread. I need a buffer. Times length. Okay. Buffer length 1 and 5. Then I'll just print it out. It probably needs no termination as well. Alright. Forgot to open it for reading. We can actually close after that. Okay, hello equals 15. There we go. So then I'm gonna convert this to a string view. So view contents equals let's see. View Caesar. Is that how I call it? View create. Alright, that's fine. View create. Yeah, then I need to pass in the buffer. And what else? Okay, size, and actually just length. Alright, then these variable contents. Okay, yeah, let me try to print it out. Percent %s. So I need PDF format. And I did a view print. View print. Alright, it's not okay. View print. You are contents. Alright, something like that. There we go. Alright, so that's how we can print it out. Yeah. And then we need to split it. Split it by space. Because it's all space separate. Yeah. So I do need to get the length of it, kind of. Yeah, because we could have like hello world equals 12, but we could also have it, I'm assuming, on the same line. So like foo equals 69, stuff like that. So yeah, that does make it a bit more complicated, but it shouldn't be that hard. So we'll need an array. Yeah, because I do have something for splitting. Let me close this out. For splitting, let's see, where is that? View split, yeah. And we have to pass the array and the array size. So I don't know the size necessarily. But I can make an array of string views. View array. I'll also make it like 128. So we can have 128 total things. Maybe I'll even define that. And use that. And then, see, I'll leave that at the, well, I'll leave it right there. And then I can do view split, and that returns the length of the what we actually use. So array length equals view split, and we need to pass array size. Actually, array size. There we go. Okay. And we need the character that we're splitting by actually, so that's gonna be a space character. Okay, so that might not exactly work. If it's a new line. So that is gonna be a thing that we have to do. But then I will iterate over this. I is less than array length. Equal plus, and just print it out. Print out the current one. So let's see, array I. Alright, let's see what we get. That's fine. Okay, yeah. So that is, that's interesting. Why did they do it like that? This one actually split properly. Shoot, I didn't add a new line, so that might be wrong. Yeah. Okay, then there's a new line for each one. Okay, yeah, that's actually fine though. So then, yeah, they're in groups of 3. Use it as an excuse to try Brave. Nice. I do like Brave. It is kind of bloated though, but really all browsers are kind of bloated, so yeah, it is what it is. So instead of a space, I'll do a new line, or a space, or instead of a new line, I'll do a space. Okay, so that is fine then. Yeah, but this one does have a new line at the end, which makes it a bit hard to do stuff with. So I need to really, if I print it out, I do trim. Let's see, what did I call it? Trim what? Trim. Yeah, trim right. You trim right of that. Okay, something like that. And then, it doesn't actually work. Worked for this one though, because before it had the new line at the end, but not on this one. Interesting. So, yeah, probably should make one to split by space. Like if it is space, then split it. I could really do that now even. So basically, yeah, basically just do the same thing. Split white space. There we go. We don't need a character then. And then just if is space, this. Then that will trim by new lines and everything like that as well. So, yeah, I think that's basically it. Let me try that. So build that. And let me change this to, I can get rid of that. But instead split white space. And I don't need to pass this. Alright, and now it worked. Okay. That's good then. Alright, so that is more what I wanted. Yeah, so now, if I put a new line on each one, you can see sort of what's going on here. It's basically an array of each different word in here. So, we do have an empty one for some reason. That's okay though. So, then we can do stuff on this. So we have it in groups of 3. So first of all, maybe I could check if the total number of elements divided by 3 is not, if mod 3 is not 0, then we could probably just return an error, because it has to be that. Because I'm not handling like anything like that, any expressions or whatever. Just numbers, names, and equal signs. So yeah. So I could probably do that then. So if actually I can just assert because it doesn't really matter. Array length mod 3 equals 0. And correct syntax. So I'm not going to give very good error messages right now. Okay, so maybe that doesn't work. What is array length? Because I might be doing it wrong. 10. Okay, so there is one extra. Why is that? Is it because I'm at the end here? Probably. So maybe I need to do mine as well. Because then it works. Hopefully it works on all of them. So what if I do another? And it does work. Okay, so that should be fine. So yeah, I can just assert for now. I can change that later. All right, and then we're basically reading it. So that's really all that we need to do. I'm just gonna assume it's properly parsed. At least to start. I can always change it up later. So yeah, basically what I need to do now is we have the name, and then we have the number, and we know where they're at. So yeah, I just need to figure out how it is structured in the actual bytecode, and then write it to that bytecode. So yeah, that's pretty cool then. So added start parsing for the language. Okay. So yeah. What happened? Did it happen again on break? Or did something else happen? Okay. So yeah. Do I need that? I need that. Don't need this one. Alright, don't need that. Okay, so let's look at the code block. The code chunk. So that and the let's see, the local function table are probably the ones that I'll need to use. And probably also the export table. Yeah, that would be important because we need the function. And it's not going to have any. The arity is always going to be 0, so we know that. The stream got down. Oh, it did. It didn't happen for me, but it's back now. Okay. Yeah, I didn't even notice that. Mine stayed up. All right. Well. Okay. So rest. What is rest? Yeah. All right. So this is the export table. So we need to encode that for the number of functions that we have. Okay. Yeah. So that's pretty easy then. Because we know the function name, because we have that right there. We know the arity, which is going to be 0, because none of them are going to take any arguments. And then I don't know what the label is. So what's the label actually? Do we have something for that? The label. What is the label? Oh shoot, those are supposed to be indexes. Okay. In the atom table. Ooh, that's interesting. Huh. So what is this then? Alright. It's all atoms referred to by the module. Alright, so atom is used. So what is an atom then? So Beam, what is an atom? Hello there, how are you doing? That's not what I want. Beam. Let's see. In Beam, what is an atom? Let's see. Symbolic constant. Okay. Alright, so that would be something. So that would be, this, I suppose. The functions there? No, it's not functions. Because this is a function, so I don't know that we need to worry about that. And I think we just need that, right? I'm doing quite well. The code chunk, okay. Subside stores that. Instruction set indicates which version, okay. Code max and label count. Function count contains the number of functions so that the tables can also be pre-allocated efficiently. So, code is that. Instructions. Alright, so what instructions do we need exactly? We just need like return that. So, parse chunks. Output works, just need to get strings working. Alright, good luck. Instruction set. Code max, number of labels, number of functions. Yeah, we don't have any strings, so we don't need to worry about that. We can just write it as empty. So it looks like we need the code. Code chunk, export table chunk, and maybe these two, but I'm not sure. And then probably the local function table. Let's see, what is that? So, let's say function, okay. Let's see. Cross-reference tool. So maybe we don't need that actually. Yeah, I don't think so. Like, I think we can just write empty data there pretty much. I'm pretty sure. So yeah. We can get started. Writing the header is very easy. Basically, we need to define a block header. Not a block header, a file header, and then write that to the file. So, let's do here. Let me actually do, let's see. Bytecode, and make a function for that. And just pass the array. An array. Yeah, we can iterate over it. So, I can create a void function. Void, and it's going to take a string view array and the array. Okay. Or just array size, that's fine. Alright, so, yeah, let me open a file. And, yeah, so again, I'm just gonna call it this. Hello, or let me just do s.b. Alright, and then I can check this. Alright. So, yeah, we can basically just create this now. Create a file header. We just need to populate it with the information. So we do need the size of the stuff generated, so we can't quite do that yet. So I don't know how that works exactly. That's interesting. Because we don't have the size of the total bytecode. So I don't know how that's going to work. Now we need to write that after. So we need to like generate the bytecode and then do this. So I'm not sure exactly, but the rest of it is pretty simple. So we need for one. So yeah, the let's see. The IF header and the form type, those are pretty easy. Type and IF header for one equals beam, right? And then the dot size, is that what it is? Size buff. Size buff. So yeah, we need to actually encrypt it. Let's see. Encode big endian of just 0 for now. But yeah, so we need to convert that to big endian. Whatever we put in here. So yeah. So I need to make a new function. Encode big endian. No, we just need a single integer here actually. Int n, and this can actually return a byte array. Yeah, and it's gonna allocate it, but that's okay. So we can do something like this, but kind of the opposite. So, yeah, I'm not sure exactly how to do this. So, we don't have buff size. But we can start at 0. And then we can do maybe we just can do it with a single one. It's only an integer, so it's always going to be 4. 4, okay. So yeah, how can we do that? Maybe big Indian. Let's see. Let's see. Okay. Is this C or C++? Alright. Yeah, okay, this is better than. Alright, so yeah, it is sort of, yeah, we need the array. Just a byte array. Array, which will be size of word. Okay, and then, size of word is this. And then, yeah, so we need to basically do the opposite of that. So buff I equals n shifted by that. So it's actually 8 times I. Yeah, something like that. So I think that would do it. And we want to return buff. But we need to actually allocate this rather than units. Alright. Yeah, we can return. There we go. Let me see if that compiles. Alright, so I messed this up. Array len. That's fine. What? Generate bytecode. Oh. Yes, there we go. Alright, unused parameter. Alright, that's fine. Let me actually just do this. This needs to actually be a byte array, so okay. Oh yeah, that's actually not gonna work. So we need to memcopy. I don't know if it's a good idea to make rot work. I made a stack that is also a queue. That's interesting. So why did you have to do that then? So you made like a deck, right? That's the one we can take out of both sides, yeah. That, and then I can memcopy. Whoops. Oh, because your stack is a linked list. I see what you mean. Copy inside that. Alright, expected that. This needs to be open for reading. Alright, we have a lot of stuff. So this needs to be a pointer. Yeah, I can get rid of this. I'll just set it to nothing for now. Alright, unused variable, shift index, yeah, so we don't need that. Need that. Alright, so unused parameter. Alright, so that should all be fine. So now, what I want to do is after this actually. Shoot, I went too far. Yeah, I want to do this into actually the f header dot size buff. Right, get rid of this. Okay. Let me just cast these to void for now. So that it does not keep yelling at me. For that. Okay, and then this, it doesn't like that. Okay, that as well. Okay. So that one, I don't like warnings, so I'm gonna cast it. And there we go. Alright. And then assertion failed. So Yeah, because desktop beam does not exist. Because we're actually writing to it. So there we go. So there we go. So we should be able to write this down. I didn't actually test to make sure this works though, so let me print that. And then decode big endian, encode big endian. 12. Let me try that. It should be 12. Let's see, and we also need the size. It did not work. Okay. So I messed something up bad. It could be in here, or it could be in the way I did this. Let me try doing this here. No, I'm not gonna do that. Alright, so I think I'm messing it up. Do I have to cast it actually? Probably do. Cast it to a byte. Yeah, I didn't change it. Okay. Uh-huh. Do I have to use and actually? Zero. That's not right. So, this goes back and forth actually. I didn't see that. No, yeah, I got the wrong. I want to do this one actually. Whoops, I didn't mean to do that. Nope. This, but make it pointer to a bytecode. Alright, do that. So, let's see. Yeah, check that. Okay. Turns that. Right. Alright, what is this? Alright, so result I is byte value shifted by 8. The size is a byte, so just need to do the string thing. Alright. Hang on. Size, no, that's not right. That's what I wanted to do. Yeah. Times size minus 1 minus I. And size is actually going to be the size of the word. Let's see. So where is this at? And let's see. Expected that, so I missed something. Yeah, another one. So that needs to go here actually. 12. Okay, there we go. Now it is actually working. So I should be able to move this 69.20 and it should still work. There we go. Alright. Alright, so I can copy that into there, and then I can write this. F right. Let me look at F right. Okay, pointer So yeah, pointer to app header, size of file header 1 to 5. Alright, actually I want to write as button. So that's what I need to do. And run this. And let's see what happens. So if I open test.b. Okay. It looks like it worked. And now I should be able to open that actually in here. So quit out of this. How do I quit it? There we go. Hex edit test.b. There we go. And now we wrote this. The size, we just wrote 0 for now. And then we wrote this. But if we write the size as, let's see. We change it to 12. Then run it. And reload this actually. Then it is now 12. There we go. So that actually worked. That's pretty cool. So that is the file header. So that is a start. That is a start. I'm gonna make it 0 for now. So we do need to change that though. So that is the only thing. So if I write this down, that sort of saves space for it. And then if we go back to the end, we keep track of how many bytes we write. Then we just basically right at the end, we go all the way back to the beginning and then overwrite what we have there. I think that would work. Okay. Yeah, so what's next? So now we have that atom chunk. So how was that structured? So I don't know what we need to put in there exactly. That is the only problem. Let's see, atom chunk. Alright, atom table chunk. So atom, we have the chunk size, the number of atoms. Okay, we should be able to generate the chunk size pretty easy. Repeat by number of atoms. So I don't know what the atoms are. That is the only problem. And do I need them? Let's see. So if I don't have anything in there, then I don't need, yeah, so I think I can just write 0, right? So if I just write the chunk size as being 0, then number of atoms as being 0. Well, the chunk size only being 4, because we have these 4 here. Then I think it would be fine. Let me try that. So, yeah, I think that'll work. Basically, we need to make a header for it. So I think I have the atom block header. Yeah, so I can use that. Block header. It has the name, size buff, and size. Alright, yeah. So I can generate that. Block header. Atom header equals that. And then dot name equals atom. And then the rest we have to mem copy. So put that there. This as well. Alright, so we take this. And then E is big endian, so we have to do it the same way. You just put 4, or actually size of word, and then 0. And I'm pretty sure that should just work then. And then write the atom header. Shoot, but we need to use atom header. Alright. Please share the link to that webpage. Yeah, for sure. So right here. Well, here, you just need this part, probably. Well, probably right here is a good place. There you go. Yeah. Elixir is awesome. It's making Erlang usable for dummies. Really. I never used Elixir, so I don't know much about it. Hey, no problem. No problem. Shoot. Where did I... There we go, right there. That's not right. I'm writing the wrong thing. Atom, size of block. Okay, compile it and run it. And sorry, what are you working on? I am doing. I can actually pull it up quickly. If you could give me a second, let me find it. I'm doing this. So that's just a link to something on Twitter, which is basically an explanation of what I'm doing. It's basically taking this file, or any file like this, and then generating Elixir bytecode for it. Or not Elixir, Beam bytecode, rather. That is what I'm trying to do. Erlang, yes. Alright, so did that actually work then? Okay, we have beam, and then we have atom right after. So is that actually how it's supposed to work? Let me look at... Hold on, beam. Does it go... No, shoot, it's at U8. So that is actually what I wanted to do. At U8. Because that is the one that was used. So, something like that. And then I'll just overwrite it, and that's fine. Alright, at U8. There we go, perfect. So then we write it, and it's all 0. So, should be fine then. Alright. Then we should be able to go on to the next part. I'm just assuming that we don't need that for now. We might need it later, but we can always adjust that. So, yeah, I'm just trying to generate some stuff. So, let's see, what is after that? So, after the at U8, then we have code header. Then we have the code. So, that is where we actually have to do stuff. So we read all that. Let's look at the, so we can make a block header now for that. What is this? Yeah, so make a block header for the code. Code header. It'll be called code. And then do the same thing. Okay, size bar. So code header. Code header. Okay. Yeah, so I'll just write nothing for now. Just like this. But I do need to actually change it. So, let's see. Did that work? Yeah, we have code and then the stuff following it. Why is this 0? That is not actually supposed to be 0. The first one is supposed to be size of word. Yeah, why doesn't that work? It should work. Let's see. The Indian folder. Whoops. Let's see. Ooh, needs to be a pointer to it. That is the issue. Shoot. Actually, no, that is already a pointer. So, yeah, I did that one. The Bytecode. Let's see. So, we can size on 4. Put that in here. There we go. Okay. Then did it actually work? Again? No. But it is working, because if I decode it now, decode size array, and also size of word in there, then it decodes properly to 4. I messed this up bad. So it's not size buff, the next one is sub size buff. Yeah, that is the issue. Okay. I'm just overwriting it. Okay, I'm just kind of stupid. So this can just be this again. Okay. Then it should actually work. Okay. And now it's actually right. Alright, there we go. Okay. Good thing I noticed that. So now. So we write that. And then we have a few of the things done. So we need to actually write the body of it, though. So what is the body? What does it look like? Code body is like that. Okay. Yes, I have. That is why I'm doing this. It was actually was the challenge sort of. Yes. That is why I'm doing this. Okay. Closing. So what do I want to do now? So I don't have that, but what do I need to write there actually? Where did it go? How's it going? It's going well. Yeah, right now. So I'm working on, yes, coding, yes, for sure. So basically what I was doing earlier was, taking the bytecode generated by Erlang, and then trying to sort of read through it and figure out how it's structured. And then now I'm working on parsing this and converting it into the bytecode. And I'm on the step of sort of writing out the boilerplate in the bytecode, like the header names and stuff like that, essentially. Yeah. Okay. Where did it go? Hang on. It was down here, beam. So code chunk. So I need to write the code. I do need to also pad, if it is not large enough. But for now it's 0. So I can probably write the rest of them just all with a size of 0, and then I can populate them with the necessary information when I need to do that. But this, I wonder if I could use that. Alright, well, let's try to go on to the next one. So only the required ones is what I want to do though. So what's after the code? Stir T. So I can write that just with 0 because I don't have anything. So that just needs a name and a buff. And I'll just make it all 0. Okay. That should be pretty easy. Let's see, it's up here. Okay, stir T name. I need to allocate. I can just write it out. Is stir T. We can have an underscore. Actually, I don't think I did. Stir T. Yeah, it's just like that. So perfect. And then this. This needs to be F right next to stir T name. Like that. Okay. And then the buffer. F right. Stir T size buff. And this. I don't want to do that. Actually. I want to do code date and date 0 because it's just gonna be 0. Size of word. Okay. Something like that for it. And this doesn't even need to be there. It can just be like this. And there we go. So if I do that, maybe F close file as well. I forgot to do that. Now if I run it, should have wrote that into there. 30, there we go. Yeah, so that one doesn't matter. It is just necessary to write that. Howdy, how are you doing? Let's get kind of big. There we go, like that. Alright, so code stir T. So then empty. So what is that again? Is that something I need? Import table. Index from that. Yeah, so I don't have any of those. We're not importing any, so I don't think I need to worry about that. I can just make it 0 again. Import count, yeah, so make the chunk size 4 and then the import count 0. So the same way I did the rest of it. So it is basically the same thing. So I just grab this. And then make this, let's see. Empty header. Empty header. Okay. Empty. And now should be right there. Alright, perfect. Perfect. Let me just make sure that is right. Empty. Oh yeah, and then export T. So we do export some. Because we do need to export our chunks. Is mandatory and contains information about which chunks are exported. Okay. So, about which functions are exported rather. So we do need the function name. Is an index from the atom table. We didn't put it in the atom table. So I don't quite maybe we do need to put stuff actually populate the atom table. So that is gonna be interesting. Because we have to export the function name. And the label, I don't know what the label is exactly. Okay. But basically, Yeah, if we just write it with 0 for now. Yeah, we write it for 0, and I think we can skip the meta. I don't think that one was required. Let's see, and then probably we need debug. It doesn't actually show that, so I don't think that's required either then. What else was, oh, the adder is probably required. Attributes. Yeah, it's optional. Okay. So, yeah, I don't need to worry about that. Any optional things I'm not going to worry about. Alright, well, I can write this for the next thing. So what was it again that we were on to? After the empty, we had the XT. So, yeah, let me actually clear replace this. Alright, and here's where I forgot that. Alright, yeah, basically just do that. Set this into capital. And that should write that. Okay. Yeah, alright, so I'll just populate it all with nothing for now. And see if we can even open it, because I'm not sure if that'll work. Yeah, so then attributes is optional, so we don't need that. What comes next? Meta attribute, then C info, so compiler info, I think. C info. Yeah, compilation information. Strings are not in the stack, so I can put them on an array, and that's it. Yeah, well, they're not on the stack, so... well, the strings and forth, you basically just print them out, right? Like, there's no variables that can store them or whatever. At least from what I know about it. Okay, the format of the chunk is that. So, it's optional. So I don't think we need that. I'm not going to worry about optional things right now. Alright, cin. And what was after that, actually? Debug. Okay. So yeah, don't need to worry about that. Line. Yeah, so what was line? I don't think that was here. Yeah, because there was this, but there wasn't the actual line thing. Yeah. So, I'm assuming that means we don't need it. So I'm not going to worry about that. And then type. This doesn't even show that, so... Yeah. So what was the type again? Yeah, so I guess that's it then. So let me try to open this and see what happens. Well, I guess just try to import it basically into Earl, and then let's see, how do I do that? Doing functions, not strings, huh? Don't know what you mean. So yeah, just how do I import it again? Import. It's not really a module. What is it? Ta-da. I need to close that. Alright. How can I import the file? Are called words sort of like a function? Yeah, they're basically similar to functions. See that. Alright, load it. Alright, so we just load. Text. Bad file. Okay, corrupt file header. Really, the file header. What is... Oh, because it's 0. So, yeah, I don't have the... I'm not writing the right thing there. So let me try to fix that. What if I just write a large number, basically? Because right now I'm just writing 0. Like I need or something. Need to actually rerun this, so... Still corrupt file header. So why is the file header broken? Alright, let me see here. Open this up. And L/L is what? So how large is this? The test.beam is 68. So let me do 60, right? 60. That should be the right number then. Corrupt code chunk. Alright, so that's the right number then. So I'm just gonna hard code that for now, and then we can actually get the right thing later. But yeah, so that's corrupt. Okay, because the code chunk is 0. So we did get through some of the stuff. It doesn't like the code chunk. Do I have to write like an empty code chunk? Let me see. Code chunk. See, how was it? Actually, it was code block or code body. Let me just grab that so I remember. Code body. Code body. Okay. Let's see. So yeah, we have those. So I really just need to write all of them. It's gonna be code body. Whoops. Code body. Code body. Dot opcode max 4. And well, let me just write 0 for it then. Whoops. Code body. Okay. Yeah. Whoops. I forgot to change the names. Label count and function count. All right. So what if I do that? Oh yeah. I don't need it. All right. And then I forgot to actually f-write it. Code body. Label code body. All right. So. Alright, then, it's not going to be right now, I think, still. Yeah, code file header, so that's wrong. So I need to actually increase it by 12. Still a corrupt file header, so did I do something wrong? Test.in 80. Oh, so now it's 80. Oh, that's right, yeah. So why is that corrupt still? I don't know why the file header would be corrupted. $48, which is 72, right? 72, 114. Oh shoot, no, I was doing nothing. 48 is 72. Yeah, that is what I want actually. So why is that corrupt then? Let's see, I need to set this size. I also need to align it all. I forgot to align it, but I don't think that matters. So code header, sum size buff. Let's see, so that means align by 4, 5. Actually change that. Alright, now build it. Run it. Corrupt code chunk. Alright, so now the code chunk is still wrong. Let me go to the code. Alright, so here's where the code starts. There is 8. Okay, so that's right then. And then we have 1. And then we have an empty one, and another empty one, another empty one. Why do we have so many empty ones? Oh shoot, yeah, because there's the three bytes, which were for that. So that should be fine then. Looking at the code one, unless I mess this up, because I don't have the function count, but that didn't work, or the instruction set rather. Sum size. Shoot, that's not what I wanted to put actually. Yeah, so I did this actually wrong. So this needs to be for each one that we have. So we have 0 there, sum size. So the extra, yeah. And then this is going to be 4 plus 12, so that'll be 16. Plus, all right. Well, actually, let me try that. That might be right. All right. No. So it's going to be. It has to be 4 more because we have to write. We have to write that as well. So right. Let's see. So this is the This goes up here, actually. This needs to be the instruction count. Let's see. For size of word. And then we need to copy the instruction count. Let's see, we want to do this, 0 again. And then want to F write that before this. And, let's see, size of word. Let me build that. Alright, so what that do? Corrupt file header. Oh yeah, because now it's not the right size again. So I need to put out of this. Let's see. And then we have the desktop beam is 84, so I just need to increase it by 4. 4. There we go. Build it and run it. Corrupt code chunk. Alright, so it still doesn't like that. So what else do I need? Yeah, so that should all be fine then. So now if I open this, let's go to the code chunk. So we have the code, and then we have the size of it. Okay, which that is 20, right? Something like that. That might not even be the right thing. 20, okay. Then they're all 0, so 1, 2, 3, 4, 5 bytes. So then 5 times 4, so that's 20, so that's right then. So, yeah, and then the rest to read is nothing, so, yeah. I don't know. I don't know why that wouldn't work. So instruction set, yeah. Must match code version. Yeah. Uh-huh. Oh shoot. Yeah. So actually I need the sub size to be equal to 16. So it is this minus 4. Because itself. It has to account for itself. Alright, there we go. Corrupt atom table. So we did move on. The atom table is actually before that though, so I don't know why that. Well, this isn't really an atom table, so it is the atom, but it is the other version. So I'm assuming it's with this. So I probably forgot something. Yeah, you probably have to write the atom body, right? Let's go to the atom table. Yeah, so I forgot to actually write these extra things. So I just wrote the chunk size as 0. So I need to do basically the same thing I just did there. So number of atoms. So it's just going to be 0. So I can just write another 0 there. Number of atoms. Size of word. And I need to actually declare that. So number of atoms. Size of word. Okay. And let me do that. So, but then I need to change the size. So the sub size, I encode that as the size. So we have this. It's gonna be 4. So it's gonna be 8 actually. So times 2. This will be size of word. Shoot. Word. Yeah. And then I can do that. Let's see. Corrupt file header. Oh yeah, so I need to extend the file header again by, what is it, 4? Let me just make sure. Test.beam is 88, so yeah, 4. That was right. Let's see. Module name and object code is that. Okay, so we are making some progress. But I do have to go now, unfortunately. I have been streaming actually for like about 3 hours. It just doesn't say that because the stream went down. But yeah, so I have gotten a good bit done today. Let me commit this and then I will end it. End the stream at least, not end it all. Okay. Yeah. Got some work done on the compilation step. Oops. Alright, I'll push that. Let's see. Tomorrow super talks. Yeah, maybe if I have time tomorrow, definitely. Okay. Shoot, I probably should have. I think that's all fine actually. Yeah, I didn't put a readme. I'll do that later. Okay. Yeah, so that is gonna be it. Yeah, this has been pretty fun. I'm making some good progress. So hopefully tomorrow can get it all compiled. So yeah, that is gonna be it. Yeah. See you guys tomorrow. Bye.